Here it says find the inverse of g of x equal to log base 33 of x. And describe the key attributes of the inverse, meaning find the domain, range, and how it's reflected. How do we find inverse? Right. Okay, good. So we're missing the key terminology that I want to hear from you first. When you think inverse, what should you think? Yes, you're right. Exponential is the inverse of log. You're right. But anytime you hear the word inverse, what should you think?
Switch x and y.
Ah, switch x and y. First, we have to switch our x and y. So x is now going to come out front.
I know.
And y is at the end. We switch the x and the y. That's what inverse indicates. And now we just have to solve for y. How do we solve for y? What do? Yes. Anytime you have the log of a variable, to get the variable all by itself, you have to perform the log rule. We do this to get it in exponential form because the opposite operation of log is exponential. If you don't like the log rule, that's okay. Just remember where each one of these terms go in exponential form. But I prefer the log rule. You start where? Yes, with the value that is being logged, the y. And you roll around till you've passed all of the terms, which in this case, we're only doing a half roll, a belly roll here. So what term do I write down first?
What? 33.
Y. Then what? Shh. Hopefully everyone's paying attention.
Equals
33. X?
to the x.
Like that? Oh. We're switching from log to exponential, so something has to be exponential here. 33 raised to x. Am I done? What is my last step in inverse? Good. You change that y to the inverse of your original function. So it's g negative 1 of x. Is this f right here? It's a g. Shh. So that's the inverse. That's what I was looking for. But then it says, describe the key attributes of the inverse, meaning domain, range, and how it's reflected. So, guys, I need you to stop talking. Domain. I'm going to go to my calculator and put the inverse into my y equals, which it already is, 33 raised to x. And then I'm going to look at the graph. Now the domain is the what values? X values. What is my least x value? Right. Remember, exponential functions have an asymptote that it gets closer and closer and closer to but never touches, right? So even though it's very hard to see right here, this graph does have an asymptote at where? What is the asymptote on this graph? 0. What equals 0? What is this line? This is the line. Up and down is the line x equals 0. What is the horizontal line? Y equals 0. The asymptote is y equals 0. So your graph does not have a least x value. It keeps going on to negative infinity. Does it have a max x value? No, it keeps on going on to infinity. So our domain is?
Negative infinity. Or no.
You can do that. Negative infinity to infinity.
That's not what I made.
Or
The bracket thing?
set notation.
Or like the little squiggles? Wait, can you explain what the E and the R is?
Okay, E is epsilon. It just means in. In. It's in it. So X is in all real numbers.
Like, what is that supposed to mean?
It means X is all real numbers.
Like, all, it can go on forever.
Yes.
Okay.
All right. Domain or range now. Range is the Y values. Do I have a least Y value?
Yes.
Yes. Do I have a value for Y that the graph does not go below?
Yes.
What is it? 0. Does it touch 0?
Yes.
Does it?
So, no, it's an asymptote.
It's an asymptote. It doesn't touch it. So, parentheses 0, infinity. It goes up forever. Or you can write
With the little squiggles.
Y such that Y is greater than. Is it equal to 0? No, so you don't put the line beneath it. Y is greater than 0. And then what line do we reflect over? What line? Every time you have an inverse, you are always reflecting over the exact same line. Every single time. What line is that? Y equals X. Every single time you're reflecting over Y equals X. That's that diagonal line, right? So if we have this exponential and this log, I'm going to really sully that. We're reflecting always over this line, Y equals X. Always, always, always.